In this video, I'll explain how to do addition and subtraction with significant figures, as well as multiplication and division. The big idea here is that the calculated answer can't be more precise than the measurements that go into the calculation. For example, if we subtract a measurement that's 1 gram from a measurement that's 3.1 grams, our answer can only be as precise as the measurement that was 1 gram. And that measurement is only in the ones place. So, our answer can only be in the ones place. It cannot have any decimal places that are significant. Similarly, when we add 6.53 grams and 2.2 grams, our answer needs to come out to 8.7 grams with one decimal place, because the measurement 2.2 grams only has one decimal place. Finally, when we add 7,500 grams and 1 gram, our measurement actually doesn't change. It would still be 7,500 grams. That's because in the measurement 7,500, the hundreds place is significant, but the tens place and the ones place is not. So adding a number in the ones place does not change our overall measurement. Here's an example to show you why. If I were to estimate how many people live in the United States, I might say about 328 million. That measurement has 3 significant figures, and the 8 is in the millions place. Basically, my measurement was plus or minus a million. Maybe it's 329 million people. Maybe it's 327 million people. My estimate is not down to the person. So what would it mean if I found out a new baby was just born? Would I change my estimate to 328 million one person? Of course not. My estimate would still be 328 million people. So 328 million people plus one person, even if it doesn't quite make sense in math class, still equals 328 million people. It doesn't change my measurement. Let's do some practice problems. 892.993 grams plus 32.8 grams gives me 925.793 grams. However, the measurement 32.8 grams was significant in the tenths place, and nothing more than that. That means that my answer also needs to be rounded to only have the tenths place, and nothing more than that. When I subtract 286.3 meters minus 234.1 meter, both of those measurements only have the tenths place. So my answer should only have the tenths place. So my final answer is 52.2 grams. Finally, when I add 300.22 milliliters and 23.774620 milliliters, in my calculator, I get 323.99462 milliliters. That answer is way more precise than my initial measurement of 300.22 milliliters. My final answer, my calculated answer, can't be more precise than the measurement that went into calculating that answer. I need to round my final answer to only have 2 decimal places, 323.99 milliliters. With multiplication and division, it's the same idea. The calculated answer cannot be more precise than the measurements used. However, for multiplication and division, we're actually looking for the number of significant figures in each measurement. 11.25 grams has 4 sig figs. 4.1 has 2 sig figs. When we divide these two measurements, our answer can only have 2 sig figs, because that's the fewest number. Similarly, for number 2, when we multiply 6.53 centimeters by 3.4 centimeters, our answer can only be as precise as the 3.4 centimeters measurement, with 2 sig figs. So our final answer needs to be rounded to 22 centimeters squared, with 2 significant figures. And finally, when we divide 24.000 meters with 5 significant figures, by 8 seconds with one significant figure. Our answer is limited by that 8-second measurement, which only had one significant figure. Therefore, our answer can only have one significant figure. So our answer is 3 meters per second. Let's finish up with a few practice problems. When we divide 178.22 grams by 185 liters, we get 0.96335135 grams per liter. That answer is way too precise. Since 185 liters only has 3 significant figures, which is less than 178.22 grams with 5 significant figures, we have to round our answer to 0.963 grams per liter, which has 3 significant figures. Again, our measurement, 185, limits the precision of our calculated answer. For the second problem, when we multiply our 3 measurements, we get 4,996.53 centimeters cubed in the calculator. However, our answer is limited by that measurement, 21 centimeters, with only 2 significant figures. So, our measurement should be rounded to 5,000 with 2 significant figures. Since that's not really possible to show in standard notation, I'm going to convert it to scientific notation, where it's clear that the 5 and the 0 are significant. 5.0 times 10 to the third centimeter cubed. Finally, when I divide 89.02 meters cubed by 10.4 meters squared, my calculated answer is 8.85961538 meters. Since 10.4 meters squared only has 3 significant figures, I need to round my calculated answer to also have 3 significant figures. And I get 8.86 meters. There you go. That's how you do math with significant figures.